Welcome back. We're working today on representing linear functions. We have 3 activities today: the Desmos activity, a GeoGebra app, and then an activity just using the Desmos calculator, and we'll be working in our slides for that. So let's look at what we've got here. I have this scheduled for one day. None of these are that long. If you're on block schedule, you'll easily finish in a day, but as I said, it's going to vary from teacher to teacher. If you have a really short class, you may have to extend it. But the first thing we're going to do is flags, which is a very popular Desmos activity. Then we're going to do a really quick graphing task. If your kids already know how to graph in slope-intercept form, they'll fly through this. If they don't, then of course they'll take a little longer. But it's supposed to be a review, so I guess this is my way of finding out what they remember from their 8th grade mathematics. And then the movie data, you could spend a long time on this, but the way I've done it, I don't think it's going to take too long, so we'll see. Let's start with the Desmos activity. Love this activity. It's got 10 screens. Doesn't take that long, but let's look at it. There's basically going to be writing equations in slope-intercept form to mirror or to mimic these flags going up the pole. So they have the height of the pole, of course, exactly lined up with the height measurements on the graph, so that makes it a little bit easier. So you'll notice this flag started at 8 and then it's rising. So you could have discussions. There are excellent teacher notes at the bottom. Please be sure to read those, and they do consider or do suggest you do pacing to restrict your students so that they're not jumping ahead in the activity. And then what's going to happen is what was the starting height, and then you can draw on the graph to show that. They can draw on it and then have them share with, maybe have a team share out or have the teams talk to each other. Again, restrict your kids' access as you go along here. And then this one's showing the speed. So what I'm going to do is I'm going to draw in change in x 1 and then change in y. That blue is what? It went from 8 to 16. So that means this is 8, so this must be 4. So they could type on here a slope triangle for what? Well, 4 feet. And then what would you put here? I'm going to put that one in red. You may wonder why I'm doing that. I used to put all my X quantities in pink and my Y quantities in blue for girl and boy. I know, that's so corny. But yeah. I did that for years. I don't really do it anymore, but I thought I'd do it here. Let's see. So here we have 4 feet per second, so you could represent the rate or slope or speed or velocity. So there's lots of words here. You may want to talk about that here because those words are all going to pop up in the course as we go through. Anyway, try to get these things out of your kids. The slope triangles are important. If they're not drawing them, direct them eventually, show them if you have to, but we want to get them to draw slope triangles regularly because we use them a lot, and then label them. What do they mean? Don't just put numbers, tell me what it means. Alright, and then another flag is added to the scenario, and your goal is to describe the behavior of the second flag. Where did it start and how quickly is it moving? So here we're just making a discussion. I would say most of your class period probably will be on this activity. I guess it depends on how much bogged down they're going to get in the GeoGebra, but I would spend time talking about this. And you may have to omit the GeoGebra or save the movie data problem for another time if they're not able to do it. Now this one, they're sketching a graph, so notice it's on the line tool. You definitely don't want to freehand this because it'll be very difficult to get it right. So our goal, let's say I just started at 8 and went up like this. I'm just going to do that and see what happens. But you see that little post that's there? The goal is to get that blue flag to be on that like on that bar that it's supposed to be on. So this was way too fast. Let's start over, and then you want to also notice, wait a minute, the starting height, it was 16, so that means the flag was here, and then let's put it here just to show you what happens. And notice the flag started out in the right place, but the flag's moving above that post, and that post is supposed to be pulling the flag, so that's not going to work. So eventually they're going to notice that they need to reduce the speed of the line by reducing its slope, and the goal is to get it to end on the graph where it ends in the image of the flag on the pole. So let them have those conversations and figure it out. And then this one, we're going from a graph, now we're using a table, so a second representation. So anyway, I'm not going to continue. I don't want to show off these answers, but they are supposed to type an expression here and check their work. If it is not correct, they need to continue. So now they're adding a flag C. They're going to describe the behavior of the flag. They're going to write an expression or an equation for that flag and check their work. And this activity, it says 45 to 60 minutes, but honestly, it should be somewhat of a review. So it should take less time. The next activity is GeoGebra, and this one should be quick. Graph a line and insert a screenshot. So there's really no work on these slides. It's just screenshots. So click here. It'll take them directly to GeoGebra, and they will be given a line. And I don't think it gives them all the same line at first. It might, but I don't think so. So I'm going to start this graph with one of these points at the 1 on the y-axis, and then we're going to go down 7. 1, 2, 3, 4, 5, 6, 7. And then we're going to go right 5. And there it is. So when you check the answer, it will say correct. And I tell them take a screenshot. Be sure in your screenshot you get the equation, the graph, and the word correct. I need to see all that, so be sure it's all in there. And take a picture and just put that on your slide. And then when they're done with taking this picture, this screenshot, they generate a new line and they do it again. So this time my y-intercept is -7 and slope is +1, so we'll go up 1, right 1, check answer, correct. Now let's do another one, and I'm going to mess it up. Let's just say I messed up and I didn't go to 10. I just went to 1, and then I did 4, 5th, and I checked the answer. It's going to say not correct, so they can't just keep it there. Now this is what's cool. You can pull this graph around. So if they press and hold and pull it around, they can get up higher to the 10. And if they want to, they can go up 4 and right 5, but they can also go down 4 and left 5. Let's see if I'm on 6, yeah. That should do it. And then it will still work. So right 4, up 5. Let me do it that way. Up 4, right 5 also works. Okay, and so they'll take a screenshot. So that's basically these slides. So notice in the notes at the bottom of the slide, these are the speaker notes. I give kids notes. So refer the kids to those. It says when it's correct, take the screenshot and be sure your equation, the correct, your line are all visible. And so they're doing 5. They have to do 5 different ones, and you have to watch them because they'll copy the same picture on 2 or 3 slides if you don't pay attention. So be sure they've got different answers. All right, now when you get to slide 7 through 10 are all the same movie data. On 7, you're simply clicking on this link and analyzing the data, just looking at it and typing something. So I'm asking them to look at it and notice at least 2 things. So click the link. It takes them out to the Desmos calculator. Here's your data. Now there are 33 rows hidden that they cannot see. So if you will click on show all, it will show all 32 rows. And oh, I can't undo, I'm sorry. Oh, but if you click off, it'll go back. So click over here and it'll go back. So they don't make you keep all that because it would be kind of hard to scroll down to use the next row with 33 extra rows in there. I'm asking them to analyze this data. You may notice it's pretty scattered. The further to the right it gets, the more scattered it gets. But the main thing I'm focusing them in on is this time past 2020. And hopefully you don't have to tell them what happened during the year 2020. But most of us quit going to the movies about that time because of the COVID virus. But I don't mention that anywhere. I'm waiting to see if the kids come up with something that might explain why the movies, there were not as many movies released in the year 2020 or 2021. And even to this year, 2024 is not on here, but numbers are down. So we can talk about that. Have them come up with that, though. I don't discuss it until they do. And this is not right. I'll have to fix that. All right, then I asked them to go ahead and do a regression equation. So we did this last time, and I told you I would have them do it again, and I'll have them do it a lot this year. So the keystrokes are actually on the slides. Y1 tilde mx1 plus b. And it makes the line. They're going to take a picture of this and a picture of their export and insert their graph. So they'll click here to export it, copy it, and paste it over onto their slide. So once they do that, here's where the new stuff comes in. This is new. Okay, so on this slide, we're going to talk about the R value, which is called the correlation coefficient. So I say that over and over again. Every time they point at it or talk about it, I call that correlation coefficient. Why is it R? I don't know, but that is what it is. And it's right here. It's actually 0.85. They're going to take this picture and paste it onto the next slide. They don't have to redo their graph or redo their equation. They can just basically copy and paste it from one slide to the next. But I'm asking them to identify that number as 0.85 and tell me what that means. And I do give them the definition down here. An R value that is +1 or -1 means it's perfect. It means every single point falls on the line. And that's usually not going to happen in the real world. So that's pretty rare. But numbers close to 1 and -1 are really nice, really good. Numbers close to 0, really bad. So if we get like a 0.1 for an R value, that means the data doesn't really fit that line. It's too close to 0. This one is 0.85. So this data, let's look at it, is pretty well fit. I tell the kids, think of grades. If you think 85% is a decent grade, think of it like that. That's a pretty decent grade. That's a pretty strong fit. So we're going to say this is a strong correlation in this data. And what does that mean? Well, the line does pretty well. I mean, there's some points here, and it seems that the points are getting further from the line as we go along, so that's not great. But the biggest point, the points that were furthest away from the line, of course, were after the year 2020. And that, I'm sure, has something to do with that R value not being a 1 or not that close to a 1 or not perfect. And then the last one we're going to do is residuals. This is new also, but it's super easy. So one thing about Desmos is they made all of this about as painless as possible. They literally only have to press a button. So they're going to press this button right here that says plot. And when they do, it's going to plot the residuals. Now all it's doing is taking those same points and plotting them above and below the x-axis to show how far off they are from that line. And so a positive residual means the point was above the line. A negative residual means it's below the line. And the further away it gets from 0, the bigger the error. The values for the residuals are actually posted in this table. You can click here to see all of them. So we have some pretty big residuals in the hundreds. -277. These last ones are massive. Big errors in the negative direction because they're way below the line. So really that's it. They're just going to plot this and they're going to look at the residuals. And what do you notice about the year 2020? Well, the residuals are very far from the x-axis. They're way down here, further away than any of these points. So, and that makes sense because you can see those points near 2020 are far from the axis. So that is the end of our lesson representing linear functions. Probably I'm going to start working on an assessment pretty soon, so stay tuned.